All right, boys and girls, welcome back to the drive-through for a special guided notes edition of the drive-through. Let's see if I can figure out how to do this. I forget how to draw over this. Okay. Well, we'll make it work. As always, this ghetto edition of the drive-thru is sponsored by the deli. Hungry? Stop by the deli. Make yourself a salami sandwich on wheat with yellow mustard. Okay, this is 2-1 guided notes. Relation. Okay? A relation is a description of one variable to another. Okay? The domain are all possible input values. Okay, the range is all possible output values. And a function, okay, is a relation where every unique input has exactly one output. A relation where every unique input has exactly one output. Okay, so there's 4 ways to represent these relations. You could write them as ordered pairs, as they're written here or here. You could write them as a map. Okay, so every time I put in a -3, I get a -4. Every time I put in a 3, I get a -1. If I put in a 4, I could get a -1 or a 3. And that's not a function, but we'll get to that, okay? You could write them as a table, or you can write them as a graph. You guys are used to doing mostly points, tables, and graphs, and that's not going to change here in Algebra 2. Okay, so we'll do some example problems. The domain, all the input values, 3, 1, 3, and -4, okay? The range, -8, 1, 0. I get confused between the commas. Okay, -8, 0, 2, and 7. Now, here's what I want you to notice. Think about this function like it's a machine. And you put a number into the machine, and then this machine does something to the number. In fact, I shouldn't put number, I should put X, because that's typically what we do. We put it in, it does something to it, and then it pops out the result. And every time I put in the X, it's going to have to pop me out the exact same result. So if I put in a 4, and it gives me a 6, if I put the 4 back in, it better give me a 6 again. Well, that is why this is not a function, because notice, one time I put in a 3, and it gave me a -8. However, later on in the day, I put in a 3, and it gave me a 2. And that just doesn't work that way if this is a function. Okay? All right, domain, 1, 3, -5, 1, 1, 3, -5, and then 1 again. So I won't rewrite it, although I could. I will. The range is 7, 9, 0, and 4. And again, that is not a function, because in the morning I put in a 1 into the machine and it popped me out a 7. But later in the day I put in a 1 in the machine and it popped me out a 4, so my machine is broke. All right. Now, another way the easiest way, in essence, to test whether or not something is a function is called the vertical line test, okay? If at any point on the graph a vertical line touches, or intersects would be the right word, but we'll just say touches, two or more points, then the graph is not a function. This is exactly what we described above, but now you can do it visually. It's so much more easy, because think about it right here. Here I put in a 0 on my graph and it gave me something negative. But here I put in a 0 and it gave me something positive. So this cannot be a function because it fails the vertical line test. In fact, it fails it all over the place. Okay? So, not a function. This one right here, everywhere I draw a vertical line, it hits exactly one dot. So this is a function. Okay? And everywhere I draw a vertical line on this graph, I only intersect the graph once, so this is also a function. Okay, so I scrolled the page down a little bit. For the given function, f of x equals negative 4x plus 1, evaluate the output for the given input. Like, this is just us making things seem complicated. It's not. Take the 7, put it in for the x, because that's what it's telling to do. X, so it's saying, for this function, if it was in terms of x, we do that. Well, now, this is actually saying, what is f of 7? So it's negative 4 times 7 plus 1. That's negative 28 plus 1. So the answer is negative 27. Okay? Put in a negative 10. A negative 10 times a negative 4 is a positive 40 plus 1. And the answer is 41. Moving right along. Okay, so next section, direct variation. Okay? Just consider direct variation to be an equation that has a slope but has a y-intercept of 0. Okay, so this is y equals mx, not y equals mx plus b. So, for each function, determine whether y varies directly. Yes. No. We don't know yet, so let's solve it for y. Y equals 3x. There's no y-intercept, so it's a yes. Okay, so using a proportion to solve for a direct variation. You guys are all over this. If y varies directly with x, and y is 4 when x is negative 2. So I tend to keep my x's on top and my y on bottom. But it doesn't matter as long as you stay consistent. Negative 2 is to 4. Look, x on top, y on bottom. Like 10 is to y. Okay? Well, you solve that for y by cross-multiplying and then dividing. So 10 times 4 is 40. 40 divided by, no, I won't skip that step. Let me show you. You get a negative 2y when you cross-multiply this way equals positive 40. So y is negative 20. That's all you do for that. Okay? Same thing for number 12. 3, x on top, is to 5, y on the bottom. Like, find x this time. Okay? X is to 25, you get 5x, is 75. And so x equals 15. Right? Yes. Okay. Still working at it. Almost done. Okay, write and graph a direct variation equation that passes through each point. Okay, so look, this is x. And this is y. Alright, so you remember the equation is y equals mx. So you just write 2 equals m times 1. This is so weird because it's so easy. Divided side by 1, you get m is 2. So our equation is y equals 2x. Okay? Here, you got x, you got comma y. The direct variation is y equals mx. Okay? So you get 5 equals m times negative 3. This one's a little harder. Divide each side by negative 3, and you get m is negative 5/3. So the equation is y equals negative 5/3 x. Okay, scrolling down one more time. If we wanted to graph that, y equals 2x. Again, they always have the y-intercept at 0, so that's y equals 2x. This is y equals negative 5/3 x. Rise over run. Rise over run. So if I go up 5, 1, 2, 3, 4, 5, then I'm going to go left 3 because I know it's got to go down and to the right. And those are your guided notes. More help later with your worksheet. Boom!